Hello and welcome back. We're doing section 3.2. These are examples from section 3.2. I have 4 of them prepared. I don't think we're going to get to all 4, but we'll see. What we're going to do, we're just going to completely analyze. We're not going to break this down into component parts, but completely analyze a quadratic function. In order to do that, these are the component parts. You have to find the vertex. That's the first thing. We discussed domain in all reals, but range. The y-intercept, the x-intercepts, that's the part where you're solving. Solving for x, the quadratic formula comes in. And then sketch it. And so that's what completely analyze a quadratic function. It means for this particular video. This is the first example we're going to do. It's a try it problem on page 213, and then again on page 219. And first off, it's not in general form, so I'm going to rewrite it. X squared minus 6x plus 13. You gotta be kidding me. I forgot this. And so, I'm going to completely analyze this. First off, the vertex is, let's see, the opposite of b over 2a is 6 over 2, 3. That's the x value of the vertex, x equals. And then the function's value at 3 is, let's see, 3 squared, 2, I think it's 4, right? I have this done already. Yeah, 4. So the vertex is 3, 4. That's a point on the graph. You can already tell the range because this opens up, and that's a minimum point. So it's going to go from 4 up, and we'll get to that. So then we got the vertex. Well, okay, the domain. I just said this, is all reals. That's redundant. It's all real for everything. For every polynomial function. The range, it opens up because that's a positive 1. So it's from 4 to infinity. Domain range, the y-intercept, right there it is. Is the point where x is 0 and y is 13. If it's in general form, it just kicks out. That's the y-intercept. We can start plotting the points right now, by the way, but no, let's keep going. X-intercept, if there are any. And by the way, right now, if you are knowing what we're doing, you'll understand there is no x-intercepts because of this range. It goes from 4 up. It never touches the bottom. So the x-intercepts, but the way we do it, this means solve. And we're going to get an imaginary. That's the point. Okay, this board goes. So we're going to solve this, and I'm using the quadratic formula. Opposite of b plus or minus square root b squared minus 4 times a times c, 4 times 1 times 13, all over 2a. That's the quadratic formula. Please familiarize yourself with that. Not just for now, but boy, next year. Quadratic formula. X equals, let's see, 6 plus or minus 36 minus 4, 13 is 50, 52, 14. Negative 14. And that's what I'm saying. That should not be a surprise. 6 plus or minus I square root of 14 all over 2. And actually we can go x equals 3. This is actually the way you write I square root of 14 over 2. That's a complex number, and it should not be a surprise. So now let's draw the thing. All right. Well, first off, it starts at 3, 4 vertex. There we go. It opens up. That's how we got. That's why there's an I there. It opens up. Here's a point 0, 13. Where is it? I don't know where. Oh, there's a point on it. 0, 13. The point where x is 0 and y is 13. Here's what I would do. The books doesn't really mention it, but there's an axis of symmetry through here. That's an axis of symmetry. And what that means is if there's a point over there, there's going to be a point over there. I mean, you fold it. This is the point 0, 13. Let's see, I went 1, 2, 3 units there. This would then be the point 6, 13. And I'll just draw it. Smooth curve. Oh, you all know my philosophy. If I ask you to graph something, graph it on your calculator first. Example 1, first example, anything else that we missed in there? I don't think. Okay, let's go to another example. I'll put it up on the same board. This is number 2. 2x squared minus 8x plus 7. 2x squared minus 8x plus 7. And we're going to completely analyze this, and which means we're eventually going to draw a graph. By the way, right now it opens up. So eventually we're going to draw a graph, and that's what we're headed for. But first we got to find the vertex. Vertex is opposite of b over 2a. X is, let's see, opposite of b, 8 over 2a, 4, 2. X is 2. Y in the vertex is f at 2, which is, put a 2 in all this. Look, or do it, no, look. 2 something. -1. I should have done it. So the vertex is at the point 2, -1. If you're cognizant of what we're doing, you'll know it opens up. You know we're below the x-axis. When we do the quadratic formula, you're going to get real numbers. There's not going to be an I in there. Foreshadow. Okay, so the vertex, the domain and range. The domain is all reals. I'm not going to write. The range, here's what I just meant, is it opens up. So that's a minimum. So it will cross the x-axis. Domain, range. Vertex, where do we head from here? Oh, solve it, I suppose. Over there? Yeah. 2x squared minus 8x plus 7. And this is what we're doing when I say solve it. We want to find out where it crosses the x-axis. So here we go. X equals opposite of b. Square root b squared minus 4ac minus 8 times 7 over 2. X equals 8 over 4, well, let's just do it like this, 8 plus or minus, that's 8, well, square root of 8 over 4, which is 8 plus or minus 2 times square root of 2 over 4, oh boy, this is a 2, plus or minus, the square root of 2 over 2. That's it. Those are the 2 points where it crosses the x-axis. Now, what does that mean? Let's see, that means where the point is 0, it's 2 plus the square root of 2 over 2. That's one of them. And then it's 2 minus square root of 2 over 2. That's another one. And we can plot those points because the square root of 2, you need to know this eventually, is 1.4. And so the square root of 2 over 2 is 0.7. So I'm going to add and subtract. This is 2.70. And this is 1.30. And so those are the 2 points. Let's just draw a graph. I'm going to shove it up here. 1, -3, or 2, -1 rather. And then, well, we can go up to 7. Up here's 1, so there'll be a 1 over here. That's this is the point 0.7. Here's 4.7. You could draw it right now. Something like that. But then let's make sure 2.70. Yeah, that's that right there. 1.30. Yeah, that's right there. It's good. It's good. Another one. I just want to do one that opens down. Just one that opens down. -x squared minus 2x plus 6. Vertex. Opposite b over 2a. 2 negative 2 over 1. It's -1. I have this done right. -1, 7, then the function's value of that is 7. We can already plot it. -1, 7 is up here. Actually, here's another point, 0.6, and it is -1, 7. You know it opens down because of that, and over here, it'd be actually -2.6. We could draw it right now. Just one more thing, let's get that quadratic formula. Let's make sure these points. X equals opposite of b, 2, plus or minus square root b squared, 4 minus a times c minus 4, -1 times 6 is all over -2. 4 plus 24 square root of 28 all over -2, -1. That's that part. I'm doing this, just talking. Square root of 28 is 4 times 7. The 4 divided by the 2 is 2. By the way, that negative will go with both of them. That's what it is. Square root of 7 is what, 1.6, 2.6, I think. And yeah, this 2 is going, it's just 1 plus or minus the square root of 7. This is about 2.6, so it's 1.6 is one of them, and 1 minus 4.6, negative 3.6 is another one. These are the 2 points where y is 0, 1.60 and negative 3.60. And I did that just to check. Whoa, there's 1.6, there's negative 3.6. Yes! Nailed it. I hope this is helpful. See ya.